All right, guys, last week's of the semester. So here we go. And I put a hashtag thank you. I'm not sure. Maybe I was going to put Thanksgiving break or, all right, well, thank you, I guess. LOL. Mean value theorem and antiderivatives. So we kind of already know about antiderivatives. Mean value theorem. So what is the mean value theorem? All the mean value theorem says, as long as you're continuous and differentiable, continuous on the closed interval, differential on the open, that the instantaneous rate of change is equal to the average rate of change. That's average rate of change here. Average rate of change. And this is instantaneous rate of change. Instantaneous rate of change. Chav, but what does that mean, Chav? When you drove from here to South Padre Island, do you guys drive? No? Yes? Okay. If you push a button on your odometer, it will tell you your average speed. So when you drove from here to South Padre Island and you pushed a button on your odometer and it said that your average speed was 55 miles per hour, at some moment in time, you were going exactly 55 miles an hour. Maybe you had it on cruise control with 55 all the way. Maybe you went above it 50. Maybe you averaged 75 and then 35, and then together it averages whatever it was. But at some moment you were going 55 miles an hour. Does that make sense? So that's all it means. If your average speed was 55 miles an hour, at some moment you were going exactly 55 miles an hour.
Is this similar to, I totally forgot the name, but you know what I'm talking about?
No. Which one? They're related, but not. Intermediate value theorem. It just means that it's somewhere in there in the middle. Kind of, I guess, if you think about it like that. But all this means is that your average instantaneous rate of change equals your average rate of change equals your instantaneous rate of change somewhere on that interval. All right, hey, relax, guys, relax. All right, what does it mean in terms of pictures? You see point A here, and you see point B. The average rate of change is whatever the slope of this secant line is. Do you guys see that? All right, look at this tangent line in blue that I'm going to put it in blue. This tangent line has the same slope. Do you guys see that? So all it means, there it is, from A to B, that the red line, that slope there is your average rate of change. The blue line, the slope of that is your instantaneous rate of change because it's a tangent line. And there it is, they're parallel, so my instantaneous equals your average. Does that make sense? All right, there it is, guys. And then so hopefully you can see the graphical interpretation. Okay, try not to say MVT. Try to say mean value theorem. So I need to change these notes. A lot of kids will say, well, I guess now, do you guys know what MTV is?
Yes.
Yeah, there used to be a channel called Music Television, but I don't think it's around anymore, or at least I haven't. It still is? Okay. So MVT, make sure you say mean value theorem, not MTV. And look, there will be at least one point on the graph where the tangent line is parallel to the chord. That's what this is right here. Meaning that its instantaneous rate of change is equal to the average rate of change. Cool, right? Remember, conditions must apply. So what conditions are we talking about? Continuous on the closed, differentiable on the open. Continuous on closed, A to B. Differentiable on open, A to B. Kind of similar like when we're saying f prime is greater than 0. So f is increasing on the closed, but f prime is positive on the open. Kind of similar to that. And then here's where it says, can you give me an example in English not using pictures or math symbols? I just used it up with that South Padre Island story. Do we understand? Okay. Is it okay if I go to the next page? Okay. If the conditions do not apply, you cannot use mean value theorem. So look at this picture here. See how the average rate of change between A and B is whatever this line is? But notice you're not differentiable on that closed interval. See? Not differentiable. So you do not have a slope or a tangent line that will be parallel to that secant chord. See, look, you have this slope. It looks like a slightly positive number. And then you have this slope. And both of those slopes are not the same as the average rate of change between that red line. Does that make sense, guys? So you must be differentiable to use the mean value theorem. If you're not differentiable, you cannot use the mean value theorem. It's that simple. Cool or not cool? Okay. All right. The mean value theorem is this, and so let's see what it says first. It says, show that the function f of x equals x squared satisfies the hypothesis mean value theorem on the interval 0 to 2. It does, because this is continuous and differentiable. So here's how it looks, 0 to 2. Yeah, I don't have any sharp corners or cusps. Do you guys see that? So it does satisfy your differentiable and continuous, or your continuous and differentiable. And then find a solution on this interval. Okay, so they want, first I'm going to find the average rate of change. So I'm going to write first, find average rate of change on 0, 2. All right, here's my point. I'm going to say that's 0. Here's my point. I'm going to say that's at 2. And I'm just finding that slope. Bless you squared, bless you cubed, bless you fourth power. You got one more?
No.
Bless you fifth, just in case. All right, find average rate of change. The function is x squared. This point is 0, 0. This point up here is 2, 4. Have I done anything crazy yet, guys? All I'm finding is the slope from your algebra 2 days. F of 2 minus f of 0 over 2 minus 0. Child, why are you doing it like that? Because I wanted it to look like this. See? See? What's up?
You know it's 2, 4. Is it because it's x squared?
Yes. Yes. But I guess I should have written this in the side. F of x equals x squared. F of 2 equals 2 squared, which is 4. And then f of 0 is 0 squared, which is 0. So here we go. I'm just going to go 4 minus 0 over 2 minus 0. Have I done anything crazy, guys? So this average rate of change is 2. And now all mean value theorem says is, okay, on this curve, is there a tangent line where I have a slope of 2? Yeah, probably there. It looks like it could be, looks like 1 just from my little picture there. Let's find out. Let's do this part right here. See the f prime of c? F prime of x equals, what's the derivative of x squared? 2x. That's my instantaneous rate of change. I'm going to equal this to 2. Not to be confused for that. That's your average rate of change. Average rate of change of f of x on 0, 2. There's 2's all over the place. Divide by 2, divide by 2. X equals 1. Are you shocked? Are we shocked? No, it looks like, just by eyeing it, it looks like at 1 you have a tangent line that is parallel to that secant. Do you guys see that? Okay. And there it is. That's it. That's how the mean value theorem is. Of course, it's going to be more special as we start doing application problems. What's up?
What's the point of using this specific theorem?
It's just, the whole point is, it indicates that for sure, if you have an average value, your instantaneous rate of change was that value somewhere. That's all. It's not. It is a big deal, but it's not like, oh my God, But it is a big deal. Check it out. Look, relax, guys. Don't rush into conclusions. It says the function f is graphed below in the interval. Give the number of values c between 0 and 10, which satisfy the conclusion of the mean value theorem. All it means, so let me go ahead and write it in words. How many times do we have tangent lines parallel to secant line? Let me explain, because I don't want you guys to become robots. The secant line between 0 and 10, the slope of that line is your average rate of change. Let me see, can I connect it with a straight line? Let me see if I can pick a color here. And it's a little off. Let me erase it. There we go. Yay, that's cool. All right, you guys ready? You see that line, that black line there? The slope of that line, how many tangent lines do I have that have that same slope? It looks like Yeah, right there. Do you see how that looks like it's parallel right there? And then it looks like another one right here. See? And then it looks like one more right there. How many do you count? There it is. Yeah, see? It's not that bad. It's not that bad, guys. I made sure, hey, no yawning. We're just coming back from break. Next one's in the parent. It's like as soon as we start doing calculus, you're gonna like, oh, I'm tired now. But I bet you if there was tacos and pizza, you guys would be like, hey, what's up? All right, I'll stop. Sorry, guys. All right, Rolle's theorem. It's a special case of mean value theorem. All Rolle's theorem is that the instantaneous rate of change is 0. And I probably should have changed my notes here because I make it look like it's 0. It says you will sometimes hear the name Rolle's theorem. Rolle's theorem is a special case of MVT, of mean value theorem, in which f of a equals f of b. Well, of course, if the y values are the same, then that means that my slope is 0. Chop, can you give me a visual? Look, if a's right here, and b's right here, look at that slope. See? So, how many tangent lines are parallel to that one? Well, every max and every min. Do you guys see that? So that's what Rolle's theorem is. See, if the y values are the same. The rules still apply. If f is continuous on a closed interval and differential on the open, and f of a equals f of b, then there exists at least one number on the interval a to b where the derivative is 0. That's all it is. It's just a special case. So check it out, guys. Example 2, determine if Rolle's theorem applies. Well, if Rolle's theorem applies, I need to find f of 0. 0 cubed minus 9 times 0, that equals 0. F of 3. 3 cubed minus 9 times 3. 27 minus 27. It doesn't have to equal 0. The difference has to be, the 0 because it should be the same thing. So, yeah, this is continuous on 0 to 3. Your differential on 0 to 3, so Rolle's theorem up, and f of 3 minus f of 0 over 3 minus 0 does in fact equal 0. So Rolle's theorem applies. Okay, let me just make sure because I don't want you guys to be a robot. You don't have to equal 0 here, guys. It could have equaled, for Rolle's theorem to apply, don't write this down because I'm just making this up. This could have equaled 5. And if this equals 5, then the other one has to equal 5 in order for Rolle's theorem to apply. So I don't want you to think like, oh, it equals 0 and it equals 0. No, it's the same y value. So the difference between the one and the other is 0 because it's the same y value. That makes sense? So I'll make sure to change this example for next year. Change.
But you're saying like the difference between like f of 0 and f of 3 has to equal to 0?
Yeah, because it's the same y value, right? It's this situation here. See, it doesn't have to, it equals 0 because that's just what it was in this problem. But if this could have been 10, the y value, and that y value could have been 10, and 10 minus 10 is 0. You know what I mean? So this is why I think this one's not a very good example because I don't want you guys to think that it's because of that. Yeah, 3 cubed is 27. Yeah, maybe I should have said that. 3 times 3 is 9, 9 times 3 is 27. And 27 minus 27 is 0. So here we go, guys. They're looking for where, and they try to trick you. All right, you see how it tells me the interval is 0 to 3? As soon as you see a negative, out and out. Because those c values are actually x values. Those are x values. It's telling what's the x value where my average rate of change is equal to my instantaneous rate of change. Your average rate of change is 0. See? That's the average rate of change. Average rate of change. And avoid writing the acronym AROC, AROC. Don't say that. Yeah, don't say AROC. Just say the whole thing, average rate of change. Don't use acronyms. F prime of x equals, what's the derivative of x cubed? Minus, what's the derivative of 9? Or, what's the derivative of 9x? 9. And I'm going to equal this to 0, because that's what my average rate of change was. This is also called Rolle's theorem, but, whatever. We're still okay? We're just solving. 3x squared equals 9. Divide both sides by 3. X squared equals 3. And then I'm going to take a what? square root, x equals plus or minus square root of 3, but you only choose one on the interval between 0 and 3, which is a positive 1. So just letter A.
And we didn't choose negative because
It's not in my interval. The interval has to be between 0 and 3. You know what I mean? And that's pretty much all it is, guys. We're just doing that over and over again. We feel okay so far? All right. Simply state the conditions are met to use the mean value theorem on the interval provided. Can I use mean value theorem between negative 1 and 1 for the absolute value of x plus 1? I'll give you a visual.
no, because it's not differentiable.
Not differentiable at x equals 0. No. Not differentiable at x equals 0. Are we okay? All right, letter B, square root of x. 0 is the endpoint, and it looks like that. Oh, it's 0 to 1. So, yes or no?
Yes.
Yes. Continuous on 0, 1. 0 is the endpoint, so it's fine. And differentiable on 0, 1, parenthesis. We're still okay, guys? Nothing crazy, right? Well, it looks like that's it. That's all we're doing for today. Now, well, this is just stuff we should know already. So this is, I put this in here because don't worry, it's going to be simple. We've already done antiderivatives, guys. All this is saying, look what it says. If f prime equals g prime at each point in the interval I, then there's a constant c such that blah, blah, blah. Do you guys understand what that just said?
Oh, yeah, that's it.
Yeah, look, it just means this. Watch. G prime equals sine x. So it just means this. What's antiderivative of sine x? Be careful. Positive or negative?
What? Because it's supposed to be, yeah.
Oh, plus guys, I really messed up with this.
Okay. Chav, what are you doing here? I don't understand. Notice how I have negative cosine x plus 1, negative cosine x plus 10, negative cosine x plus 100. When I take the derivative of negative cosine x, you do get sine x, right? And notice the antiderivative of all of these just differ by a what? By a constant. And that's what they're saying here. Then there is a constant c such that blah, blah, blah for all x on that interval, where they all differ just by a constant. That's all it is. And if they give you a scenario or they give you an initial condition, it doesn't have to be initial. That's just a word. They can just give you any condition. We can find that c value. Usually, you guys, we're at the high school level. Usually, they will give you quote unquote the initial. Do you guys remember when you guys did physics and they would talk about initial and blah blah? It's the same issue. But as you explore mathematics more and more, you don't have to. It doesn't have to be the quote unquote initial. It could just be any value, and then from that value we can figure out what the c is. Does that make sense, guys? All right. So here it is. Look what they tell me. Find the function f of x whose derivative is sine x. Okay, so I'm just going to write f prime of x equals sine x, and whose graph passes through the point 0, 2. So f of x passes through 0, 2. So that means f of 0 equals 2. That's all it means. Are we still okay, guys? All right. Antiderivative of sine x. Negative cosine x. That's what we just did. Plus c. The derivative of cosine is negative sine, but I don't have a negative. I have a positive, so negative cosine x. Do you guys see that, guys? All right, here we go. I'm going to plug in what value? 0. And I'm going to equal it to 2. So 2 equals negative cosine of 0 plus c. A little bit of pre-count, not much. What is cosine of 0? 1. So this is negative 1 because of the negative in the front, plus c. And then how do I get rid of that negative 1 there? Plus 1 plus 1. So my c is? Now that I know that c is 3, rewrite it. F of x equals negative cosine x plus 3. And there it is, guys. It's true if you plug in wait, let me check. Yeah, if you plug in a 0, you do get a 2. Because cosine of 0 is 1, but there's a negative in front. Negative 1 plus 3 is 2. Do you guys see that, guys? Yeah, there it is. Yeah, so all these are just, look, antiderivative of the function. So we already know this. We already know. Who used to say that all the time? DJ Khaled? DJ Khaled. Right? Doesn't he say that all the time? Or maybe you guys don't know who that guy is? DJ Khaled?
DJ Khaled goes, "We the best music."
Oh.
Another one.
Another one. Yeah. So he doesn't say we already know. Then who says we already know? We already know.
Good job, DJ Khaled.
DJ Chop.
Yeah.
Okay. So we're just taking antiderivatives, guys. It says find all possible values of x. Underline the word all possible. Because it says all possible, you must put the letter C when doing the antiderivative. Does that make sense?
Yes.
All right. What's the antiderivative of x? You guys remember?
No.
So reverse the operation and do the opposite. So when we did the power rule, when we took a derivative, you took the exponent and you multiplied, and then we subtracted, right? Reverse it and opposite. So add 1 to the exponent and divide. Hopefully I said that right in English.
Oh, it was
So this is the power 1. What's 1 plus 1?
2.
So x squared and divided by 2. And then put the plus c. And then check it. Does it work? Yeah, it works. If you take the derivative, you get x. I don't know, maybe you guys want to rewrite it like this. Maybe you want to write it with a half in the front like that. I don't know. They're both the same, guys. They're both the same. They're both the same. Yay or nay? All right, letter B. F of x, 2 plus c. And then you can just check it. If you take a derivative, do you get 2? Yes. Do you see how we're doing it? Okay, polynomials, I think they're just straightforward. All right, tell me this one. X cubed minus. There you go. See, add 1 to the exponent, divide by that number. 3x cubed divided by 3, the 3's cancel out. Do you guys see that? 2x squared divided by 2, the 2's cancel out. Plus x plus c. It just takes practice, that's all. Make sure to put the plus c in there, guys. I'll wait for you guys to catch up. F of x, what's the antiderivative of sine x? There you go. Ooh, letter F might get you guys. We'll see. Letter E, antiderivative of e to the x. E to the x. Put the what? Plus c. Let's see if you guys remember letter F. Let's see if it's been too long. What about letter F?
Ew, I don't like that.
Yeah, so it hasn't been too long. F of x is ln, and actually it's absolute value of x minus 1, but we'll talk about that as we get closer. Plus c. Yeah. All right. Have you guys ever seen this symbol?
Yeah. I've seen them on calculators. I just never know what it means.
Okay. That for now, we're going to do a whole proof of this because without the proof, this is just magic. For now, that means antiderivative.
Oh, okay.
Yes. Chop, where's that dx? Why is that differential there? You need to have that dx for all of them. So let me go ahead and let me write better notes. So what this means is this: integral f prime of x dx, and I better have that dx there. So make sure it's in there. That means this: f of x plus c. Do you guys see what we did there? It's just a definition. For now, it's just a definition. We are going to do the proof of why this is that. This is called an integrand. Integral symbol. And just like it says, look, f prime, and then look at what it spits out, f of x. So what is it doing? It's doing the antiderivative. Does that make sense? So if you feel better, f prime of x equals 2 over x squared. That's what f prime is, right? Look at my definition up here on the side. So let me rewrite this: 2x to the negative 2. And we're going to do the same as we did before. So I'm going to write f of x. What's the antiderivative of this? So what do? I add 1 and divide by that number. So 2x to the negative 1 divided by negative 1, right? You add and then divide by that number. And then I put a plus what? C. Making it pretty. So let's see, negative in the front, 2 over x plus c. There it is. That's my derivative. That's my antiderivative, sorry. Are we okay, guys?
So that means that it's our original function.
This is my antiderivative. This is my derivative, and I have to go backwards.
Yeah, so the
Yeah.
f of x is our
Yeah, this is my original. And if I take a derivative, I better get 2 over x squared. And you do. Are we okay with that, guys? All right, so what about this one? Chav, I don't know how to do this one. Yes, you do. If you're dividing by one term, here it is, f prime of x equals 3x cubed over x squared minus 4 over x squared. If you're dividing by one term, you can do that. So it's the algebra that's going to hurt us. Are we still okay? Okay. Antiderivative. Well, I'm not doing anything just yet. These x squares cancel out, so I get 3x. And I'm going to leave this one. I'm just going to bring that x squared up. So I'm going to write it as 4x to the negative 2. Is everyone okay? Okay. Here we go. What am I doing? I'm doing the what? The antiderivative. So I'm finding my original. What's the antiderivative of 3x? 3x squared divided by 2. Add 1 to the exponent, divide by that number. We're not done yet. Minus 4x to the what power? Negative 1 divided by negative 1, and I put plus c. So what's your original? Let's see, 3/2 x squared plus 4 over x plus c. If you wanted to find a common denominator, or I guess, let's not go there. That's fine right there. Do you think this is hard, or? Okay, well, it's just the algebra, guys. It's just the algebra that might hurt us. All right, ready for this one? I'm going to go slow. I'm going to change my colors. F prime of x equals 3x squared plus, and then that's 7 with the square root of x. Turn that into an exponent so you can use the power rule for integrals. 7x to the 1/2. I haven't taken anything. Plus, and then bring the x cubed up. X to the negative 3. Are we okay, guys? Okay, here we go. F of x, your antiderivative. What's the antiderivative of 3x squared? Let's go slow. To the third divided by, so what's going to cancel? So it's just going to be x to the third. X cubed, perfect. Okay, this one I'll go ahead and go slow. Plus 7x, what is 1/2 plus 1? 3/2 divided by 3/2, which is the same thing as multiplying by? Perfect. So I'm going to put times 2/3 like that. So 3/2. Is everyone okay? Don't worry, we're going to fix it, just not yet. Plus x to the negative 3, so I'm going to add 1. So that's going to be what? X to the negative 2 divided by negative 2. And then I put a plus what? C. All right, let's fix it. Did we go slow enough? Or should I go slower? Okay. All right, so here we go. F of x is equal to the x to the cube. Let's leave it alone, x to the cube. What is 7 times 2? 14. So all right, plus 14 over 3x to the 3/2. You can also say square root of x cubed, but I like it like that. Minus 1 over 2x squared plus c. I think we're good. I don't see any issues. How do we feel? Is this the last one? Yeah, there's the last one. Yeah, see, nice easy day, guys. Nothing crazy. All right, here we go. F prime. I'll do this one in blue again. f prime of x. I'm going to leave the 1 over x like that because that one's pretty straightforward. But the 1 over x squared, I'm going to bring that x up. X is negative 2 plus 2x to the negative 3. Okay. Y'all ready? Antiderivative of 1 over x. ln. Put the absolute value on it. If you don't put the absolute value, that's okay for now, but it should have an absolute value. Plus, add 1, divide by that number. So what is that? Yep. X to the negative 1 over negative 1. Plus, and don't worry, we'll fix it in a little bit. Add 1 to the exponent, divide by that number. Plus c. How are we feeling, guys? All right, here it is. F of x equals ln absolute value of x minus 1 over x minus, the 2's cancel out, 1 over x squared plus c. Do we feel okay? What's up?
What is integral? Is it just the antiderivative period?
Well, it means a lot of things. It means area under the curve, and it means summation. This is as far as we're going to go for now. We're going to do the proof. We're going to do everything. But for now, that integral just means antiderivative. For now. Are we okay, guys? Don't worry. YouTube, don't hate me. We're about to do the proof of this. We're about 2 weeks away from it. We haven't done the proof. We'll do the proof of why that is. We're not there yet. Cool or not cool, guys? All right, that's it, guys. There's a delta.